Okay, structures. Well, we are in the data structure class, but data structure is a little different kind of topics. In this slide, the structure is a structure from C program language, okay? So they are, in a sense, they are related, but in a sense, another sense, they are different kind of words. Okay, structure or struct is a collection of data items. Each item may differ in type, so heterogeneous type can be part of this structure, one structure. So let's take a look at this example. So we have one structure for a person, okay? So here we have character array for name and integer variable for age and float variable for salary, okay? So we can have different types of variables in the one structure. So I think you're already familiar with the structure from C program language, okay? Okay, and we can make an instance person1. So this one is kind of data type, okay? So this one is a type and person1 is one instance. It's something like this. When we have an int a, then int is a variable type and a is an integer variable or instance, okay? And once we have a structure, then we can declare another structure variable person2. So in this case, we'll talk about this definition, type definition later, but in this case, we don't have type def, so we have to use this one. This struct t person corresponds to int, okay? Struct t person is a type, okay? And once we have an instance, person1, then person1 has some data members like a name and age and salary, right? So to have an access to these data members, then we need a dot. So person1.name, person1.age, person1.salary. But if it is a pointer, so person1 is a pointer to the structure, then we can have this operator, arrow operator. So we'll talk about it later. Okay, so why do we have a structure? Okay, so structures explicitly represent the relation among attributes. What does that mean? Okay, so think about this one. We have 20 persons. Okay, then each person has its own name and his age and salary, etc., etc. So let's say each person has like a 5. In this example, each person has a 3 attribute or data field. Okay, then without the structure, we can use arrays. Okay, but for the names, we need the 20 character array because one name corresponds to one character array, like in this case 10. So we need 20 character arrays for names, for 20 persons name. And also we need 20 integer variables as an integer array, okay? And then we need a float array for 20 float variables. Okay, so if you really want to, then you can implement something with these arrays. It's fine. It's not beautiful, it's a little ugly, but it works. So as long as you want to make a program only working, then it's okay. But it's not recommendable, it's ugly. Because it's not easy to understand the relationship between the attributes. When we look at these 3 arrays, then we know, oh, we are making 3 arrays for 20 persons. We know that, so it seems like we are not confused with these 3 arrays, but when we look at your own code like 10 months later, then you will get confused. Believe me, sometimes we can get confused with our own code. But if we use a structure, then it will be much easier to understand. So in this example, we have struct t person, okay, and then in each person we can have a name and age and salary. So we have an array of a structure. So since we have an array of structure and each person has its own name and age and salary, then we don't need an array for names or age and salaries because we have an array for structure. So when we implement something like a contact, then if we don't use a structure, then we have to handle all these arrays. But if we have a structure, then we can manage all the persons with one array, which is an array of structure. So in this example, it's not that terrible with arrays, right? But what if one person has lots of attributes, lots of data fields, data members like name and age and salary and the birthday and birthplace and parents' name and brother's name, and so if we have like 100 attributes, 100 data fields, then this approach is not manageable, right? So this one is way much more efficient and simpler and easier. Okay, as I just mentioned, and we can use type def for the structure to define our own data type. Okay, so we have type def struct, and now human being is a type name like int. Okay, so from now on with this statement, we can use this human being as a type like int, or we can have this. We can define struct t person as a human being. Okay, actually, I summarized a couple of different ways to define the structure data type, or to make instances of the structures. So you can declare one instance in this way. So in this way, we are not defining the structure data type. So if you want to use the data type, then this is kind of data type. And in second, this one is a data type. So when we declare one instance, yes, this one is a data type, which means this one corresponds to something like int or float or character or some things, right? Int a. So this one is a data type, and we make one instance. So this one corresponds to int, and person one corresponds to a. Now, by corresponding, I mean struct t person is not integer. They are different. Okay, I mean struct t person is a type like int. That's what I'm saying. Okay, or we can define our own data type like this. So it's a little different from this one, right? So here we have a same kind of structure with the name and the age, but we have a type def struct. Now t person is a type. So instead of struct t person person one, t person person one is totally fine, because we defined the type. This structure is defined as t person. Okay, so likewise we can define our structure in this way too. Okay, so let's talk about structure a little more issues. So first one, comparison. Okay, so in C, we cannot compare two structures directly. Let's say we have two persons, person one and person two. So if we want to compare these two persons, then this would not work. Person one and person two, this one will not work. Okay, and think about the two arrays. So when we compare two arrays, let's say array 1 and array 2. If we compare these two, okay, then we are not actually comparing the element of the arrays. We are actually comparing the address of these two arrays. Okay, because when this one is an array, right, something like int array 1, 100. Once we declare our integer array, then if we use just array 1, it means the address of this array, the address of this array's first element. Okay, so basically we are comparing the address of these two arrays. Okay, but in the program we can do this. Compiler will not complain about this, but you should know what you are doing with this. And the second, assignment. So when we have two structure instances, person 1 and person 2, this statement will copy all the members from person 1 to person 2. Okay. So in the previous slide, each person has a name and age and salary. So by this, person 1's name will be copied to person 2, and person 1's salary will be copied to person 2, and person 1's age will be copied to person 2. So person 2 will get all the copies from person 1. And think about the assignment of array. So array 1 is array 2. This is not allowed. This is not legal. Why is that? Array 1 has memory space, and array 2 has a memory space too, right? So they have their own memory space. Then what if C allows you to do this? What if this is legal, then array 1 will have the address of array 2. I mean, array 1 will have the address that array 2 is pointing, which means array 1 will give up its own memory space. Then there is no way to have access to that memory space that array 1 was pointing. So we are losing that memory space. Then if this is legal, then we can have a memory loss, memory leak. So it means if this is illegal, then C is allowing you to have a memory leak officially. That should not be possible, okay? That should not be legal. So this one is not allowed in C program language. Okay, so arrays and structures, they have a similar aspect and different aspect. They are kind of collection of some values, right? In that sense, they're similar, but arrays are for homogeneous elements, and the structure is for heterogeneous data types. Okay, and we can compare two arrays' address, but we cannot compare two structures. Okay, and then we can assign between the structure instances, but we cannot assign between the arrays. Okay, then what if we want to compare two structure instances? What if we want to check if person 1 is the same person as person B? Okay, then we have to implement a function to check. We have to check all the data fields. So person 1 and person 2, compare person 1 and person 2. We have to compare person 1's name and person 2's name, and we have to compare person 1's age and person 2's age. So if they have different names, then we return false. If they have different ages, then we return false. If they have different salaries, then they are different people. So we have to implement this comparison function. So once you define your own structure, then probably you have to define these comparison functions if you want to compare. Okay, and the next issue about structure is how to use structure as parameters. Okay, so we want to pass a structure as a parameter. Okay, so we have a structure here. Then in the main functions, we have one structure instance A. Then we call this print functions passing A. Okay, so we have a print function. Then what happens? Do you remember here we have assignment for structures. So if we call these print functions, A will be copied to the local variable A. So this A and this A, these are two different variables. This one is the variable in the main functions. This A is variable in the print functions. And by calling these print functions passing A, then we are copying all the members from this A to this A. Okay. So we print out A's name. Perfect. And there is another way. Instead of passing A, we can pass the address of A. Then in these functions, we need a pointer. We need a structure pointer, P. So P is pointing A now. Then we can print A's name like this. P is pointing A, so P arrow name is actually A's name. So let's compare these two styles. Which one is better? Sometimes you might want to use the first style, but most of the time this one is better. It's more efficient. Why is that? Okay, think about this in memory. Okay, and let's assume that we have lots of data fields here. In this example, we have only 2, but let's assume that we have lots of data fields. Then if we call these print functions, then we have to copy. So basically this one, print function will get the copies from the structure A. So if we have a lot of data fields in the structure, then we have to copy all of them. That's terrible sometimes. If we have too many data fields, so it will take a lot of time. But in this case, we don't copy anything. Instead, we just point, P just points A. So P can have an access to A's data field. So we are not, in these functions, we have to allocate the memory space for A first, and then we have to copy all of them from this A to this A. So it takes a lot of time. But in this case, we don't have to allocate memory space, because just one pointer means just 4 bytes. Okay, 4 bytes, that's not that huge memory space. That's just tiny little. Okay, so memory allocation is fine, and then we don't have to copy anything, just we can point. That's why this style is much better than this one. Okay, and we can have a structure as a data field of another structure. So in this slide, we have a really good example. So let's say we have a structure for a date. So in this structure, we have a month and day and year. Okay, so it's a perfect structure. And now, in this structure, we have a name for this human being, and we have another data field, and we can have date of birth as a data field. And date is a new data type here, which is a structure. So we can have a structure instance as a member, so date of birth. Okay, so once we have this data type, then human being John will make one structure instance John. Then we can have an access to all the data field. John.name will have an access to this one, or if you want to have access to this data fields, then john.dob.year. Okay, that's how we can have an access to this internal structure. Okay, and the next one is about the memory structure of structure. So internal representation of structure is a little bit different from maybe what you expect. Okay, so we have a padding. So basically, if we have this kind of structure, then the character will occupy just 1 byte, and int will need 4 bytes and short will need 2 bytes. Then actually, if we calculate the sum of these size of members, then it will be like a 7 bytes. So we need 7 bytes for this structure, but that's not that beautiful. That's a little ugly, right? So every time if we read the data, then if we allocate memory space, then we allocate just the 7 bytes. And if we have an array, then we have 10 elements of this structure, then we need 70 bytes. Okay, then every element occupies just the 7 bytes. 7 bytes and 7 bytes and 7 bytes. That's not that beautiful. So memory alignment will improve the efficiency on the many CPUs. So basically, it's based on the 4 bytes or 32 bytes or something. So instead of having this ugly number, then we can have a padding here. So now we have 12 bytes instead of 7 bytes. Now, in the memory structure, we have a beautiful alignment here. So yes, we have a little loss of this memory space, but that's okay. Okay, the next topic is, you learned all of these kind of topics already, so we are refreshing your memory. Okay, so next topic is the structures. So next topic is linked list. The linked list is, we can have a self-referential structure with the structures with this link. So in this structure we have struct till link, which is a struct till link pointer link. Okay, so that in this list we have a data, and at the same time we have a pointer, and this pointer can point struct till list variable. Okay, so we have 3 list items, item 1, 2, 3. Okay, then item 1 dot data can have A, and item 2 data can have B and C. Okay, etc. And then item 1 dot link is a struct till list pointer, which means link can point any other instance of list. So item 2 is an instance of list, so that item 1 dot link can point item 2, which means item 1 dot link can have the address of item 2 as its own value. This one. Okay, likewise, item 2 link can have item 3's address, and item 3 link can have null. So by these 3 lines, we are making these 3 pointers. So we will have this graph. So we can represent these lines with this graph. So item 1 data is A, item 2 data is B, item 3 data is C, and item 1 link is pointing item 2. It's not pointing item 2's data. It's pointing item 2 itself. Okay, item 2 link is pointing item 3. Okay, so we can use this linked list in a really beautiful way in a while loop or for loop. Okay, so we have one pointer, list pointer. Okay, and then we declared item 1 in the previous slide, so PTR is pointing item 1. So now PTR is pointing item 1. Now, as long as PTR is not null, okay, if PTR is null, then it is false. If it is not null, then it is true. So as long as PTR is not null, then we will repeat this while loop. And PTR is not null, then it will print PTR's data. The PTR's data means it will print out the data of the structure that PTR is pointing. Okay, so PTR is pointing this item 1. So PTR arrow data means the item that PTR is pointing, the data of the item that PTR is pointing. Okay, so PTR is pointing item 1, so PTR data means A. Okay, so now PTR is PTR link, which means PTR link is the address of PTR2, sorry, item 2. Okay, so PTR link is pointing this one because PTR is pointing item 1, so PTR link means this one. So by this assignment, PTR is actually pointing this one. Okay, good. Then in the next iteration, still PTR is not null, and when we check PTR's data, it is B, and then PTR will get the PTR's link. PTR's link is this one, so PTR is pointing item 3. And then next iterations, PTR is still not null, then PTR data is 3, and then PTR will get the PTR link, which is null. So now, at this moment, PTR will be null. And then when we go back to this, PTR is null, so we will quit. That's how we follow this linked list. Okay, so we will have a practice. Okay, so as a practice, we will make a contact application. So contact means, we can add someone's name and a phone number and email address and some other informations. Okay, and then we can save, and sometimes we can search, sometimes we can sort, etc., etc. So basically, we can read and we can edit and update and everything. So before implementing all of them, so as a first step, why don't we implement this one? Read and parse lines from a file first. So in the file we have all the informations in this format: name, semicolon, birthday, semicolon, email, semicolon, phone number, something like this. And we have lots of lines. Okay. And we can assume that to simplify the problem, we can assume that in this contact we can have only 999 persons in our contact. Okay, then you can use an array of structure and add the data into an array of structure named contact. Okay, so in this contact structure we need the name and birthday and email and phone number. Okay, so when we read this from the file, then we have to parse, and then we have to save all this information to our structure